Hello students, let's study the motion of center of mass is independent of internal forces concept. With the help of this example, a projectile following the usual parabolic trajectory explodes into fragments midway in air as shown. The center of mass of fragments of the projectile continues along the same parabolic path which it would have followed if there were no explosion. Linear momentum of a system of particles. You know that linear momentum P is the product of mass and velocity, and it is a vector quantity, and by Newton's second law, force is the rate of change of linear momentum. Consider a system of n particles with masses m1, m2, m3 and so on, and moving with velocities v1, v2, v3 and so on respectively. The particles may be interacting and have external forces acting on them, and their linear momentum will be m1 v1, m2 v2 and so on, and the sum of the linear momentum will be p, and that will be the vectorical sum of individual momentums. Thus, the total momentum of a system of particles is equals to the product of the total mass of the system and velocity of the center of mass. Differentiating it with respect to time, you got dp by dt equals to mdv by dt, and dv by dt is acceleration and mass into acceleration is force. Therefore, dp by dt is the external force. And if the sum of external forces acting on a system of particles is zero, then momentum will be conserved. It will be constant. And this is the statement of the law of conservation of linear momentum of a system of particles. Example, let us consider the radioactive decay of a moving unstable particle like radium. It disintegrates into nucleus of radon and an alpha particle as shown. So the total linear momentum of the system will be same before and after decay, as external forces on the system are negligible. The two particles produced in the decay will move in different directions in such a way that their center of mass moves along the same path along which the original decaying radium nucleus was moving. If we observe the decay from the frame of reference in which the center of mass is at rest, the motion of the particles looks particularly simple. The product particles move back to back with their center of mass remaining at rest as shown. In astronomy, it is another example. In astronomy, binary stars is a common occurrence, and the trajectory of two stars S1 is shown by a dotted line and S2 by solid line, forming a binary system with their center of mass C in uniform motion. If we go to center of mass frame, then we will find that there the two stars are moving in a circle about the center of mass, which is at rest. Thus, in our frame of reference, the trajectory of the stars are a combination of uniform motion in straight line of the center of mass and circular orbits of the stars about the center of mass.